Let's have a look at the following integral for this function. First, I want to draw the graph. The function is x to the power of 3 minus 4x. And here is the graph for that function. Now, if I would like to find the integral, so in this case it would be from -2 to 2. So all the area between the curve and the x-axis, and here this part of the curve and the x-axis. So this area and this area. Okay. First of all, we have to know the lower limit and the upper limit. As we can see in the graph, it seems like it's -2, 0 to 2. But just to make sure, we can add calculator page, and let's solve this function. Menu algebra. We have the solve function. Since we are in the same, this is called a problem. When it's 1, 1, 1, 2, all the pages start with 1. That means that if we have a function here, which is the first function is f1, it will know what f1 is, even though we're in a calculator page. So I'm just going to write f1 of x is equal to 0, and then always comma and the variable is x. Now we see that we have the zeros, x is -2, x is 0, and x is 2, and that's what we suspected. So basically I would like to find out, I would like to calculate the integral of this function from -2 to 2. So let's do that. We go to the calculator page, and I can either go here in the template button and choose this one, or I can go to menu and calculus. Number 3 is integral. So from -2 to 2, and the function is, let's use f1 again. So f1 of x, and then dx, which means that the variable is x. And the result is 0. Why? This seems a little bit strange because we have an area here, right? And we have an area here. The thing that we have to understand is that the area above the x-axis, which is this part, will count as positive, and the area below the x-axis will count as negative. And since the area of this part and this part is equal, this minus this will be 0. So we have to remember that if they just ask us to find the integral or evaluate or calculate the integral, this is the answer. The integral from -2 to 2 of this function is 0, the integral. But if they ask us to find the area between the curve and the x-axis, it's this part and then this part, then we have to do it a little bit differently, because an area can only be positive. So then we have to divide up this integral into 2 parts. So how about we find the area of this first, and the lower limit is -2, the upper limit is 0. So let's just find the area of this one first, okay? So let's go back here, and then we can actually go up, up, and then press enter. We just copy this expression, and then we just change the limit from -2 to 0. So the area is 4 units squared of this part. Now we can see that this it's the same thing on this side, so we know that the total area would be 8 units squared, but sometimes it's not very symmetrical, so let's just do this anyway to make sure that it's 4 units squared as well. So the lower limit will be 0, the upper limit will be 2. So let's go back here. I want to find out the same integral. Enter. We're going to go from upper limit is 2, lower limit is 0. And now the result will be -4, because remember the integral is going to be negative if it's below the x-axis. But since we know that we are finding the area, we just take the first part, which is 4. The area, we just ignore the minus sign. The area is going to be 4. The total is going to be 8 units squared. Okay. That's everything I have to say about this function, I think. So to sum it up, we had to divide it into 2 parts. First this one, and then this one to find the area. The integral, we just enter it as it is. And in this case, the integral was 0.